Thank you very much. Really excited to be here. And today I want to talk about how we can apply EEG to neuromarketing research. And it's interesting because the neuromarketing or consumer neuroscience, the term that is currently being used more and more often, as a field is fairly relatively young. It's about 20 years old. But the need for this field started actually way back when the first, there we go, when Amos Tversky and Danny Kahneman started doing their studies trying to understand consumer decision making, like how people actually make decisions. And traditional economists and traditional marketing folks thought that all of the decisions were rational. All of the decisions were conscious, and you can ask a person, and the person is going to tell you why they're buying the product they're buying and why they're making the decision they're making. And through multiple studies that Tversky and Kahneman did in the 70s and 80s, they actually showed that a lot of the decision-making happens outside of conscious awareness of the person. And what does happen is that we have kind of these implicit or unconscious processes that like become a fundamental part of the decision-making process, and then we use conscious processes to modify, shape, kind of explain to ourselves why we make decisions that we make. Most of the shopping experiences that we have are fairly automatic. You go to a store, you're going to pick up a product that you probably actually used to. So things like habits and implicit heuristics play a big role in how consumers actually decide on their purchasing behaviors. Also, and sometimes, you talk to the marketing people and they say, oh, well, it's the small things that are under unconscious control, but things like cars, buying a house, buying a car, buying a refrigerator, these have to be rational, right? But what actually studies show is that even with these kinds of big purchases, people get a feeling for the house first. People really like the color of the car. And then they rationalize why they want that particular car over another. This is why when you go to a car dealership, they can actually entice you with things that are probably not going to actually cost that much for them to put in a car, but will make the car more valuable to you. Same idea with the house. If you try to sell a house that is staged, where a person who is buying a house is going to come in and they have a feeling of like living in the house and they can imagine themselves being in the house, versus when you have an unstaged house, the prices that clients or customers are willing to pay for the staged house is much, much higher than for the unstaged house. And so this kind of idea of both system one and system two working together for in terms of decision-making process, in terms of purchasing behavior of consumers, is what gave rise to the neuromarketing field. Because traditional researchers will just ask questions. They will ask questions and they will say, okay, how much do you want to pay for a product? How often would you buy it? Would you buy it, just try it once, or would you buy it again? And these kinds of questions, they're useful, but they're also missing a big part of this unconscious implicit processing that plays a really big role in decision making. And so about 20, 25 years ago, different companies started to emerge using different techniques that would allow us to study these implicit unconscious processes of consumers. What kind of different tasks or methodologies can we use to study these implicit and unconscious processes? So we're going to actually start with something that is used fairly commonly among different companies that offer System 1 research, and it's implicit tasks. So these can be divided into either implicit reaction time tasks, where participants are asked to press a button to a certain stimulus, and then they measure reaction time, and the idea is that the faster participants respond, the more implicit processing is involved. There are some problems with that rationale, but this is fairly commonly used today. Also, there's implicit attitude tasks. Basically, when you ask participants to associate a certain product or brand with positive and negative attributes, and then you measure reaction time. And again, the faster the reaction time, the more tightly attributable or connected the brand or the product is to the attribute. The problem with these tasks is that because they're behavioral, there's always a contribution of both implicit and explicit processes, and you can maximize or minimize one or the other, but they're always going to be there, both. And so it's hard to completely get rid of the explicit processing. And on top of that, some of the rationale that companies are using is actually not quite accurate. Another methodology that is commonly being used today is facial coding. Facial coding is something that goes back to Ekman and his facial coding system, where identifying different muscles associated with different emotions can tell you what person is experiencing, what kind of emotion person is experiencing. This today is mostly automatized. You have a lot of different algorithms that will read out facial expressions and give you the output. These are great when you have a really strong emotional stimulus, like movies, TV shows. These are not as great when you have something like a commercial, because even though some commercials will maximize laughter or humor, other commercials are going to be, pretty much devoid of emotion. And so, these kind of facial coding tasks are not, or measures are not always great. Eye tracking is also one of the most common methodologies that is used today. This is pretty simple, where you kind of really figure out where participants are looking when they're examining a product, a package, or advertisement. A lot of the times, EEG, eye tracking is equated with attention, but we know that it only gives you the kind of focus of visual attention. You can be looking at something and not really paying attention to it. And sometimes you can actually pay attention and notice things that you're not directly looking at. So there's some limitations of eye tracking, but it does give us an important indication of where consumers are looking during our studies. And then finally, EEG. EEG we use pretty, as a primary measure of how participants are feeling as they're exposed to different types of marketing materials or products or packaging. And in the lab, this is how it would look like. We have today in our labs, we have 32 biosemi system. We have a trained neurophysiologist who monitors participants. They monitor their EEG, they monitor eye tracking, they monitor their kind of what they're doing through the video camera. And so they have a control over the experience. What are some considerations for kind of a good neuromarketing firm? When we go to a client and you say, hey, we do neuromarketing or we do consumer research, they will ask you questions, and they will ask you questions about veracity of your claims, how well you're prepared to answer their questions, and do you actually know what you're doing? So in this space, the first thing that is really important is the infrastructure. You need to make sure that you are present in all the different markets that your clients are interested in. You need to make sure that your study and environment is really tightly controlled. EEG, like as we all know, is susceptible to different source of noise, electrical noise, movement noise, but also if the design of the study is such that you're mixing different potential cognitive processes, then your EEG measures are going to be less useful, because now you're going to be contaminating and kind of mixing together different emotional cognitive processes that might be happening. You have to have a really good data analytics to clean the data. to really extract information from the EEG and marry EEG data with eye tracking and facial coding so that you have a holistic understanding of how consumers are feeling and thinking when they're look at different products and advertisement. You have to have reliability measures. You have to make sure that what you are measuring is reliable. If you measure it today, that you're going to get the same results tomorrow, that you're going to get the same results a month from now. And finally, you have to make sure that your measures are valid. You have to validate it against in-market performance. You have to validate it against behavioral indices of consumer preferences and choices. And this is something fundamental for every client relationship, because they don't care about what you think these measures are representing if they're not connected to their sales numbers. If you can't actually elevate their predictive power from the regular questionnaire measures that they've been using for years, like what is the incremental power of your EEG results to help them predict whether a product is going to be successful, whether a commercial is actually going to lead to increase in sales. So in Nielsen IQ basis, what we are currently using are actually three primary measures that we derive from EEG signals. These are based on academic research, studies that have been replicated, and that we are pretty confident that we are measuring what we think we're measuring. For emotional motivation or a measure of lean in, we actually use frontal asymmetry, a measure that's been researched pretty well and indicates a kind of approach versus withdrawal for a product, for a stimulus. For memory activation, we use frontocentral theta. Again, EEG measure that is pretty well documented to be involved in encoding and retrieval of information. And for attentional processing, we use, again, well-established alpha measure, where increase in alpha indicates a decrease in focus and attention. We have a measure that is a combination of the three, and so this kind of tells us whether the participants are engaged with the stimulus. And then the combination of emotion and memory give us a measure of action intent, whether participants are willing to change their behavior or act on the message of a communication in the commercial. This measure of action intent actually been really well validated and predicts in-market performance of different advertisement with a high degree of certainty. We also use ERPs, and we use P300 and late positive component to indicate whether a communication or a product or a packaging actually conveys the brand that the client is interested in. So if you expose participants to different brands before the stimulus, you show the stimulus itself, and then you measure P300s to the brands again, what you can get is this pre to post increase in P300 if the communication of the commercial or product was actually successful in promoting that particular brand. You can do the same thing with messages, so attributes. So instead of brands, you would show different attributes in the pre to post fashion. The way we, there's different applications for this methodology in the market research world. We can study packaging, we can study and understand how participants and consumers look at different packages in isolation versus on a shelf versus at points of sale. We can look at advertisement, both traditional video advertisements as well as digital, audio, and billboards. We can actually test products and see how participants are experiencing different products in terms of taste, smell, and touch. And finally, we can study different attributes of the brand, whether consumers are liking the brand, whether consumers are trusting the brands, and what elements of branding is the most important for a consumer. So, for example, for McDonald's, we know that the golden arches is the most important element of branding for McDonald's. What are these elements for other brands? And so this is pretty wide range of applications that we have in the neuromarketing world. And we can basically go to any big company and have ability to measure system one processes of their consumers. I want to give you a couple of examples of how different EEG readouts can be used to track consumer behavior. So the first study that I want to kind of highlight is a study that we did a couple of years ago during Super Bowl 50. As we know, Super Bowl is really big time for commercials. Most companies invest millions of dollars in creating commercials and then buying time during the Super Bowl for their commercials. But some of these commercials are more successful than others. We analyzed tweeting behavior of consumers during Super Bowl 50, and what we saw was that there was a big range of in how much people tweeted about different commercials. So the gap was thousands of tweets. The top 6 ads gathered about 70,000 tweets on average. The bottom 8 about 3,000 tweets on average. And this actually didn't depend on categories. So it's not about a particular company that was advertising or a particular category. It probably just depends on how successful was the creative itself. And so we analyzed, we showed these commercials to our participants in the lab, made sure that they did not see these commercials ahead of time. And then we analyzed their EEG data. And what we found is that the top ads had much higher performance on our memory metric than the bottom ads during the branding periods. And so what it tells us is that the ads that are successful because they really make their branding pop and they make it memorable. And if you make something memorable, then people are more likely to discuss it and tweet about it and probably go and buy the product. Another study that we did also relates to tweeting activity, but also viewership activity per se. So we looked at different primetime shows, and we selected 9 episodes from 8 primetime shows, and these were ranging from Survivor to NY Med. So there was a wide range of different shows that we had, and each of them was 1 hour and either drama or live action. We showed these episodes to over 300 participants. Each participant was a regular watcher of a particular episode, a particular show. We asked them not to watch the latest episode. And so when they came to the lab, they were naive and they did not see the show, but they had to see the previous episodes of the show to be able to participate. And we got sort of 3 sources of data. We have our EEG data. We have the data from Twitter. Here we're looking at the number of tweets that are show related that were shown that were tweeted during the regional presentation of the episode. And then we have the TV viewership data, which is minute by minute data from Nielsen ratings that tells us how many people tune in or tune out to a particular show as it was aired originally. When we looked at the data, what we found is that a composite measure that is a combination, like linear combination of emotion, memory, and attention was the best predictor of both Twitter and TV viewership. So we get a really high correlation across different segments of the episode. So what we did, we actually, for each of the episodes, we broke it into different segments that were in between commercials. And so we looked at the performance of these different segments And what we see is a high correlation between tweeting during those segments and viewership of those segments and the composite EEG measure. But then we wanted to kind of break it apart and see whether emotion, memory, or attention play a bigger role in tweeting behavior or watching behavior. And what we found is that for TV viewership, attention was pretty much the only measure that was required. So as long as you were paying attention, there was a really high correlation between attention metrics and viewership numbers. But for tweeting, it was actually a combination of attention and emotion. So it wasn't enough to just pay attention. You also had to have an emotional response to the ad, or to the show in order for you to tweet. And so what we see is that for different types of stimuli, whether it's a show, whether it's a commercial, different cognitive and emotional processes can relate and lead to certain behaviors. So it's not that the same measure of EEG is going to always be a predictor of every human behavior. We have to be careful, and we have to choose and test which consumer behavior is going to be predicted by which cognitive processes and will be indexed by which EEG measures. And finally, I want to just touch upon something that we are currently working on and the future direction that we want to take with, in particular, EEG processing for consumer research. And today, most academic and commercial work that is being done in this space is actually done on canonical EEG bands. So we talk about alpha, we talk about theta, we talk about gamma, and these are preset frequency windows that we normally take. But what we know is that there's a lot of variability across different participants or different individuals. And there is more than just power within a frequency that is important for cognitive processes. If we parameterize EEG signals, and we'll look at different things like central frequency, we'll look at the width of the frequency peak on a power spectrum. We'll look at the aperiodic activity and offset and the exponent. Then all of these different features of the EEG signal can be informative and can correlate with different cognitive processes. And what is most important is that across different participants, there is a lot of variability. So if you look at this graph, and I know there's a lot of different things on this graph, but in panel A, what you see is there's a young participants and older participants, and what you're seeing is the distribution of power spectrum within the alpha frequency range. And you can see that there's a lot of variability, not only in the amplitude of alpha, but also in the central frequency. And even when you look at panel D, where you see the exponents across multiple participants, you can see that aperiodic activity also has a lot of variability in both offset and the exponent of the aperiodic activity. And so in order for us to start actually maximizing our signals, what we need to start doing is actually looking at individual differences, and instead of discounting them, using them to our advantage. And so identifying specific central frequencies and bandwidth for each individual, and then using that information to average across groups gives us better power and minimizes noise and variability, and actually allows us to decrease sample sizes. That is ultimately is going to make us more profitable as a commercial organization, but also provide better data for our clients as well. And finally, I would like to thank my colleagues at Nielsen IQ, in particular the R&D department, as well as our collaborators at UC Berkeley and UC San Diego. Thank you.